Example, find a bilinear transformation which maps the circle w modulus is less than equal to 1 into a circle modulus z minus 1 is less than 1 and maps w equals to 0 and w equals to 1 respectively into z equals to 1 upon 2 and z equals to 0. Solution, let the transformation be w equals to a z plus b upon cz plus d equals to a upon c z into z plus b upon a upon z plus d upon c. Equation 1. Here the circle w equals to 1 correspond to the modulus z minus 1 equals to 1. So the points w and 1 upon w bar inverse with respect to the circle modulus w equals to 1 correspond to the points z 1 plus 1 upon z bar minus 1 inverse with respect to the circle modulus z minus 1 equals to 1, because the inverse point of a point A with respect to the circle z modulus z minus equals to r is c plus r square upon a bar minus c bar. In particular, w equals to 0 and infinity correspond to z equals to 1 upon 2 and 1 plus 1 on 1 upon 2 minus 1, that is w equals to 0 or infinity correspond to the z equals to 1 upon 2 and minus 1, because w equals to 0 when z equals to 1 upon 2. From equation 1, w equals to 0 and z plus b upon a equals to 0, which implies z equals to minus b upon a, which implies b upon a equals to minus 1 upon 2, and w equals to infinity, which implies z plus d upon c equals to 0, which implies z equals to minus d upon c, which implies minus d upon c equals to minus 1, which implies d upon c equals to 1. So from equation 1 becomes w equals to ac into z minus 1 upon 2 upon z plus 1. Equation 2, since w equals to 1 correspond to the z equals to 0, so equation 2 implies 1 equals to ac into 0 minus 1 upon 2 upon 0 plus 1, which implies ac equals to minus 2. So that equation 2 becomes w equals to minus 2 into z minus 1 upon 2 upon z plus 1, that is w equals to 1 minus 2z upon 1 plus z. This is the required bilinear transformation.